Imagine a star. Not just any star, one that died in a colossal explosion, collapsed into something so dense that a teaspoon of its material would weigh 1 billion tons. And yet, it spins hundreds of times per second, shooting deadly beams of energy across the galaxy like a cosmic lighthouse. Now imagine hearing click, click, click from the depths of space. Not a hum, not static, a steady, repeating signal. Precise, rhythmic, unnatural. That's what astronomers heard in 1967. It was so bizarre that they called it LGM1, Little Green Men. Because what else could send such a perfect regular signal from across the universe? But it wasn't aliens. It was something even stranger. This is the story of pulsars, space's most bizarre timekeepers, alien signal decoys, and tools that could one day help us map the galaxy and listen to the echoes of colliding black holes. So, what exactly is a pulsar? Let's rewind. Picture a star 10 to 20 times more massive than our Sun. When it runs out of fuel, it explodes in a spectacular supernova, blasting its outer layers into space. But at the heart of that explosion, the core collapses under its own gravity, compressing into something unimaginably dense, a neutron star. Now, if that neutron star has a strong magnetic field and spins fast, it becomes a pulsar. A pulsar is like a cosmic lighthouse. It shoots out beams of electromagnetic radiation from its magnetic poles. And because the magnetic axis is slightly tilted compared to the spin axis, those beams sweep across space. If Earth happens to be in the path of that beam, we see it as a repeating pulse of energy every time the beam points toward us. Just like a lighthouse blinking in the fog. They're tiny, only about 20 kilometers across, but they can weigh more than the sun. Imagine cramming a mountain into a sugar cube and then spinning it 700 times a second. That's a millisecond pulsar, by the way, and we'll get to them soon. Okay, let's go back to that creepy repeating signal in 1967.
That bit of the sky due to go through the telescope beam at 2 o'clock, 3 o'clock in the morning. December the 21st, perishing cold, and I switched on the high-speed recorder and it came blip, 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 blip. Clearly the same family, the same sort of stuff. And that was great. That was really sweet.
Jocelyn Bell, a 24-year-old graduate student in radio astronomy, noticed an unusual blip on the chart recorder. It was repeating perfectly every 1.3 seconds, over and over. Nobody had ever seen anything like it. This wasn't random static or noise. It was too precise. It honestly looked like someone or something was sending a signal. The team didn't panic, but they did jokingly name it LGM1, Little Green Men. For weeks, they secretly wondered, had they just discovered an alien civilization? Was this our first contact? Eventually, more of these signals were discovered. They were too numerous and too consistent across different parts of the sky to be alien signals. What they had found was something entirely natural, but just as thrilling. The first known pulsar. No aliens, just the universe showing off. But here's the kicker. Even though we know they're natural now, some scientists and SETI researchers still keep an eye on pulsars. Because if aliens wanted to send a galaxy-wide signal, pulsars would be the perfect tool to hijack. You think your smartwatch is accurate? Let me introduce you to the real MVPs of timekeeping. Millisecond pulsars. Some pulsars spin so fast that they flash hundreds of times per second, like a cosmic strobe light. The record holder, PSRJ 1748-2446 AD, spins 716 times every second. That's like a skyscraper-sized ball, spinning faster than a blender on turbo mode. But here's the wild part. These pulsars are so regular that they're more precise than our best atomic clocks on Earth. Astronomers use them as cosmic metronomes, tracking the tiniest shifts in time and space. In fact, pulsars are now being used in a concept called pulsar-based navigation, a kind of galactic GPS. Instead of relying on satellites like we do on Earth, future spacecraft could use the unique pulsing signals of known pulsars to determine their position anywhere in the galaxy. You're literally reading star signals to find your way through space. How cool is that? Here's where it goes full sci-fi. But it's real. Pulsars aren't just cool spinning stars. They're also tools. Tools we can use to detect gravitational waves, the invisible ripples in space-time predicted by Einstein over a century ago. So how do we do it? Well, because pulsars are so incredibly precise in their pulsing, scientists treat them like cosmic clocks. If a gravitational wave passes between us and a pulsar, it stretches or squeezes space ever so slightly. That tiny disturbance changes the timing of the pulses we receive, just by a few billionths of a second. But with the right instruments, we can measure that. This is what's called a pulsar timing array, a galactic-scale experiment, where astronomers monitor dozens of pulsars across the sky, all acting like motion sensors in space. If they all shift in sync, it means something massive, like two supermassive black holes merging, is shaking the fabric of the universe. And in 2023, scientists finally did it. They picked up the faint hum of gravitational waves rippling through the cosmos, not from one event, but from many, like a low, cosmic bass note playing across space. And the key? Pulsars, little stellar corpses acting like ultra-sensitive antennas across the galaxy. Pulsars didn't just detect gravitational waves, they helped prove they exist. Let's rewind to the 1970s. Two scientists, Hulse and Taylor, discovered a pulsar locked in a binary dance with another neutron star. They noticed its orbit was slowly decaying, exactly as Einstein's general theory of relativity predicted it should, if gravitational waves were leaking energy from the system. And guess what? The pulsar's timing matched Einstein's math perfectly. This was the first solid, indirect evidence that gravitational waves were real. Einstein once thought we'd never detect them. But thanks to pulsars, dense, dead, fast-spinning stars, we proved the universe bends and ripples just like he said. It's one of the greatest physics confirmations in history, and it came from the heartbeat of a dying star. Okay, thought experiment time. What if a pulsar was close to Earth? Let's say it appeared where the moon is. At first, it might look beautiful, a spinning jewel in the sky, pulsing with ghostly light. But beauty quickly gives way to terror. A pulsar that close would fry our planet with high-energy radiation. Its magnetic field, trillions of times stronger than Earth's, would distort our atmosphere, destroy satellites, and shred our ozone layer. Electronics would fail, radiation sickness would spread, and within hours, life on Earth could be extinct. Basically, you don't want a pulsar as a neighbor. From a distance, they're fascinating. Up close, they're cosmic death blenders. Luckily, most pulsars are far, far away, thousands of light years distant, safe, but still watching. So, what have we learned? A pulsar is more than a spinning corpse. It's a lighthouse, a clock, a probe, and a megaphone from the universe itself. They helped confirm Einstein's theories. They help us listen to gravitational waves. They could guide future spaceships, like a galactic GPS. And for a brief moment, they even made us wonder if we'd found aliens. Pulsars are one of the most bizarre, brilliant byproducts of cosmic destruction. And who knows, maybe one day, deep in the pulse of an old neutron star, we will find something unnatural, something deliberate. Until then, they remain the universe's most reliable beat.